So I'm going to jump in and do a video for section 1.1. It's probably going to go into 3 sections, possibly 2. What I have on the screen right now is just a piece of paper that I printed out by following a link on my website. I clicked on the link that said text and problems and printed out the document. So my lecture is more or less going to follow the best I can, whatever I already typed up. You don't need to open up anything. You can just follow along the video and it's pretty self-contained. And maybe I say you don't need to open up anything. It wouldn't probably hurt if you followed the answer tab on my webpage and opened up the answers for this section. That way, when I have you do problems during the video, you can check to see if you're right. I'm just going to put my iPad off to the side right now, and I'm going to start lecturing. I actually took the time to print out the answers for this section so I can tell that I'm not making a million mistakes as I do my videos. And it might not be a bad idea if you have access to a printer and if it is more convenient for you. Anyways, the first handful of problems in section 1.1, they're not on this page yet, but they involve this table that I typed up. I typed up a table because we're going to have to take sentences and translate them into algebra, and this table kind of gives you a feel for what we're going to do. Each of the problems at the beginning of section 1.1 will have a sentence or something that I put a period at the end of that's probably not really a sentence because grammar and me don't work well together. But somewheres in the problem, there'll be a keyword and some more words. And we're going to use the keyword along with the additional words to change the sentence fragment into symbols. I'm going to just jump right into doing problems. As I'm going to need to refer back to this page over and over and over again. And for each problem I'm about to do, I took the key line that I needed and put it with the problems. So if I start looking at the first few problems, the instructions for problems 1 through 24 say translate to an algebraic expression. An expression doesn't have an equal sign. An equation has an equal sign. So I'm going to take the sentence fragment that's given and just transform it into symbols. And I'm not going to have an equal sign. You'll notice that on my screen right now I have 4 problems. I'm going to do most of the even problems in this video. Your homework's going to be to do the odd problems. What I would suggest as you're going through the video is that you'd watch me do an even problem and then you do the corresponding odd numbered problem. Pause the video, do the odd numbered problem, and check your answer. It'd be the best thing to do. So the first problem I'm asked to do is I'm going to do is number 2, which is the expression or the sentence is 1/3 the amount comma a. This comma a tells me that when I create the algebraic expression, the letter that I want to use is the letter A. And for our class, instead of saying letter, I'm going to use the word variable. Variable because the value of the letter is going to vary from problem to problem. So I went to my table and I saw the keyword in here. It says 1/3 of the amount. Of is the keyword. I looked for the keyword of, and next to the keyword of, I had a sample phrase that says 1/4 of z. Tells me to use z for the variable. And the word of is a multiplication. And it's a multiplication that's fairly straightforward. So to get an answer to create the sentence 1/3 of the amount A into an algebraic expression, just symbols and numbers without an equal sign, for 1/3, I'm going to use the fraction 1/3. And then for of means multiply, so I'm going to put a symbol that means multiply. And then what I'm multiplying by, I'm taking 1/3 of the amount. And then rather than writing 1/3 times the word amount, I'm going to write the symbol that's going to represent amount, which is the letter A. this would be an acceptable answer for problem 2, but if you had a number right to the left of a variable and you didn't have a time sign between, that multiplication is assumed. So when I go to write my answer for problem 2, I'm going to say just 1/3 times a is the algebraic expression that has the same meaning as the sentence that's given to me. If you pause the video and tried number 1, I looked at the key word in yours. The key word in yours is twice, and twice is another word that's buried under multiplication, and the sentence that I translated was twice x. I made it into 2 times x without the time symbol. So maybe pause the video and give your problem 1 a try. I'll show you that my problem 2 is correct, and if you do problem 1, that's what you should get for your answer. I'm going to move on and do problem 4. Problem 4 asks me to take this sentence, the length times the width, and parenthetically I put an L in a parentheses. I'm probably going to write my L like that, otherwise it's going to look not like an L. The length L times the width W, and I told you that to represent length I want to use the variable L, to represent width I want to use the variable W, and then the key word in my sentence was times, and from my table the times row said 12 times y is going to be equivalent to 12y. So times is just a straight multiplication. And in this case, instead of multiplying a number times a variable, I'm going to multiply 2 variables. My answer for number 4, translating the length times the width into an algebraic expression, which is a problem without an equal sign, it's just going to be LW. When I write the variables next to each other, the multiplication is implied. So you should be able to do problem 3. I took the row from my table and put it on the screen for you. And if you want to real quickly, you can check your answer for 3 just like I can check my answer for 4. Those are pretty straightforward. Multiplication is not the tricky way, usually it's not very tricky. The next few problems start to get into a little more of a trick, because less than is a subtraction word, which is not a deal for number 5. But sometimes when we have addition words and subtraction words, the order of that the numbers and variables are presented need to be switched when we're translating it into algebra. And that's going to be the case for number 6. Number 6, the key word is more than. So I went to my table and I just cut it and pasted. So I looked for more than, which is an adding word for me, so I'm going to get a plus sign. And in more than, here, when I wrote the phrase 8 more than z, more is an adding word, but it's a special kind of adding word in that the order that the variables or numbers and variables are presented, it's going to switch when we go to make our algebraic expression. So 8 more than z, the more than gives me the plus sign. The word more than forces me to switch the order. So when I go to do problem 6, 8 more than a number n, the more than is going to give me the plus sign, and it's a special kind of plus sign in that I'm going to switch the order of the 8 and the n. I'm adding 8 and n, but more than implies that I need to switch the order. So the best answer for number 6, I use n for the number, the plus for more, and then plus 8 because I'm adding n and 8 in this case. Your problem 5 is very similar. Less than, even though it's not an adding word, it's a subtracting. It's a subtracting that you switch. So the less than, the word less than implies I'm going to get a subtraction or a minus. But when you go to create the subtraction problem, you have to switch the order of what's presented. Here I'm presented with a number and a variable. And 10 less than the number z transformed to z minus 10. Your problem 12 should work similarly. Let me move on to 8, and you can work with number 9. On number 9, it's a subtracted from. Subtracted from is another word that's a minus word, and it's another kind of subtraction just like less than that you're switching. So immediately from my table that I yanked this from, I looked for subtracted from, found it under subtraction, so I know I was going to have a minus sign, and then I looked at my phrase, and my phrase kind of indicated, well, this is a subtraction and I need to switch the order. I don't expect anybody to memorize this table. I mean, it would be nice if you were kind of familiar, didn't have to refer to it every time, but when we do a test over this chapter, I will give you a copy of this table, so you don't have to fret with memorizing when you switch the order, when you don't. Won't worry about that. So let me work with my number 8, which is a difference. And difference is another subtraction. And when I look at my words, the keyword difference of, it's from the subtraction part of my table. So I know I'm going to have a minus for my symbol. And for difference of, the order doesn't switch. So here I'm finding the difference of the length L, which I'm going to use an L like that, and 6. I'm just going to subtract them, and I'm not switching the order. So part of the confusion when you're trying to create these algebraic expressions is to know the order that you need to put your answer in, or the best order to put your answer in. And that comes completely from the table. I kind of tried to do that work for you. So you should hopefully be able to do 5 and 7 on this page. Eventually, and this is where we're at, now we're getting into evil trick, the big trick. So I paired a 9a and a 9b, a 9a straightforward, 9b similarly worded trick problem. And I have a 10a and a 10b. 10a non-trick, 10b similarly worded trick problem, and I'll try to explain to you what the trick is. So as I'm going through 10a, I'm just going to go in order. The first thing I'm going to do is I'm going to find 4 times x and make that into a symbol. And times is just straight multiplication. That's kind of obvious. So the 4 times x part of this for number 10a is going to be 4x. And then the next word that I see, well, that's an easy word, that's plus, but I have to make sure that the word plus doesn't switch the order, and it doesn't. My example for 11 plus y, the 11 comes before the plus sign, the y comes after the plus sign. So the plus sign comes from the word plus, and I'm adding 4x and 3y, and plus, you're not switching the order. So for my answer to 10a, should be 4x plus 3y. That's not the trick part. The part B's of these are the trick parts. So maybe you should pause the video and give part A of 9 a try. Now I'll move on to 10b, assuming you paused the video and gave this a try. So the horrible thing, the big difference between 10a and 10b, 10a says 4 times x, 10b says 4 times the sum. So before the x and after the 4 times, there's the word sum, and that is evil. So here, 4 times x, that is just 4 times x. Here, I have to do 4 times the sum, and that means for orders here, what I have to first, I have to find the sum of x and 3y, because that's what I'm multiplying 4 times. So I'm going to find the sum of x and 3y first. Sum is another word that means plus, and it's a plus that doesn't change the order. So I'm going to find the sum of x and 3y, and that's just going to be x plus 3y. That would be the sum of x and 3y. And now I want to make and multiply 4 times this. If what I did next, so to finish, I'm going to do my 4 times part. And if I did this for my finishing, if I just said it's 4 times the sum of x plus 3y and wrote that for an answer, that would be wrong because that's actually 4 times x plus 3y. It's not 4 times the sum. And these problems where you have to do a sum first or a difference first, you need a parentheses. And so for the 4 times part, instead of multiplying just 4 times the x, I'm doing 4 times the entire sum. And to do 4 times the entire sum, I have to put the sum in a parentheses and then multiply it by 4. That's an evil trick. We're going to get about 4 or 5 problems in this section that have the same evil trick. So give 9 a go, and we'll keep plodding along. 11a and b have the same strategy, and maybe I'll do 11a and b with you and not do 12. Maybe pause the video and try to do 11. If you can't, then I'll do it for you. But pause the video, try 11, try a and b. If you got them, you got them. If not, I'll do this for you. So if I read through 11a, first of all, the word half, I probably need to make into the fraction 1/2. And of is a word that means multiply. And what I'm multiplying by is x. So this is half of x. This part right here represents half of x. That times sign that I put between, I probably shouldn't write. And I messed up, but I'll fix my mess up. So the beginning of this is just half of x. And then it says minus 2y. Well, for some reason on my table here, I cut and pasted and cut and paste the right piece. So for minus 2y, minus is another subtraction word. And when I look at my example, 8 minus y, the 8 comes first, the y comes second. It's a subtraction and it doesn't switch the order. So for the minus part, it's going to be minus for the word minus, and I'm just subtracting 2y. So the answer for 11a, or the best answer I can think of for 11a right now, is going to be 1/2 x minus 2y. When I go down to b, there comes to be a difference. It's a different problem. I use a slightly different word because it just worked out grammatically better. But first of all, 11b starts out with half of. Half is the fraction. Of means multiply. And I'm not multiplying by x. I'm multiplying by the difference of x and 2y. So what I need to multiply by the 1/2 by is the difference of x and 2y. So I need to figure out what the difference of x and 2y. Different means subtract, and it's a subtraction that I don't change the order. So the difference of x and 2y, like the difference of x and 1 is just x minus 1. The difference of x and 2y is just x minus 2y. Now I want to find half of that difference, and if I don't put it in a parentheses, I'm going to get the answer above, which is just half of x, not half of the difference. So for my answer to part B of number 11, I need to take half of and the difference of x minus 2y and jam those in a parentheses. All right, let's keep plodding along. A few more of these double trick problems. So you should be able to try to do 13. At A and B, I will do 14. And I have some flexibility with division words. And the words in 14, at least one of the words in 14, come from division. Quotient is a division word. And when I'm writing something as a division problem, I could form a fraction or I could use a division sign. They're both going to be correct. And I have a tendency to use fractions more so than division signs, but I'll show you both. So for problem 14a, I see the quotient of z. So this first part in 14a, the quotient of z and, I should box this, the quotient of z and x. I need to divide two things. The quotient of is a division or a fraction, and you take them in order. So the quotient of z and x is either going to be z divided by x, or it's going to be z over x. I make my z's with a line through them like this because my writing is just so wretched that sometimes my z's start to look like 2's, and I don't want that to happen. So that's the first part of 14a. That's the quotient of z and x. Now I'm just going to tack on minus. Minus is a subtraction, and you keep the order. So from that quotient, I want to minus y. So either the fraction version of the quotient and subtract y, or the division version of the quotient and subtract y. These are both correct. The second answer is probably the one that I would prefer. If I was making a key on my test, that's the one I would instinctively write. And when I look at my answer key, I only gave the second, I didn't give the first. For 14b, it wants me to find the quotient of z, which is fine, but I'm not finding the quotient of z and a single variable. I'm finding the quotient of z and the difference. So first, just like in the last few problems of the part B's, first I need to do the difference, and then I'll worry about the quotient. So I'm going to do the difference of x and y, and that's just a straight subtraction. The difference of x and y is just x minus y. And now I'm going to do the quotient of it. And for quotient, so I need to take z and divide it by this difference. And in order to do that properly, I should do a parentheses. Anytime I have to do a piece first that has an adding or a subtracting, I should sneak that into a parentheses. So now I'm going to do for my answer the quotient of, which means divide or make a fraction, the quotient of z and the difference of x and y in a parentheses. That would be a perfectly good answer. This would be a perfectly good answer. And it turns out that if you're needing to write a fraction, that the denominator kind of makes the parentheses not necessary. The x minus y in the denominator without a parentheses will still have the same meaning. The fraction bar almost works like a parentheses. So both of those would be okay for part B of number 14. So try to give 13 a go. Let me flash the answers up here just in case you need to see. 13a and 13b. Those are the fraction version, the slickest versions. You can have an answer that has the division sign that would still be equally correct. I just don't want to overload answers in here. But if you get an answer that's slightly different than mine, that's highly possible because a lot of times when we're working algebra problems, we can get multiple answers that look different but are equal to each other. All right, so I'm going to move on to 16, and you can try 15. 16 starts with 2 times the length, and for 2 times the length, times is just multiplication. I'm just going to multiply the 2 for the number 2 and the length L. I use more of a capital L, otherwise it will maybe look like the number 21. And then plus is just an addition word, and I keep the order. So plus, and then twice the width. Twice is just multiplying by 2, and what I'm multiplying by 2 is the width. So my answer for 16 should be twice the length plus twice the width, or 2 times the length plus 2 times the width. Your problem 15 is remarkably similar. And I'm going to move on to 17. Actually, I'm going to move on to 18. On 18, it's 3 less than 5 times the length. So less than is a subtraction, but I need to switch the order. So I know immediately when I see the word less than that I'm going to get a minus, but I'm going to need to switch the order. And I'm switching the order, this hardly looks like minus there. I'm switching the order of the 3, which is going to go after the minus sign, and the 5 times the length, which is going to go preceding the minus sign. And 5 times the length, I would just write as 5L. So my answer for problem 18, less than is subtraction, but it's a switch order subtraction. So I made the minus for the less than. I switched the order by having the 3 second and 5 times the length first. I think we're at 25 minutes. I'm going to pause and do a part 2 to this video so it doesn't get so long.